First you have a field equal to x, y and z, which is then equal to field 1, field 2 and field 3. Field 1 is then equal to x squared e to the yz. Field 2 is equal to y squared plus log of xz. And field 3 is equal to z squared all over x plus 2z all squared. The curl is denoted as follows. On the top line you have E1, E2 and E3, and then you have the partial derivative of x, the partial derivative of y and the partial derivative of z. And on the bottom line you have field 1, then field 2, then field 3. This can then be written as df3 over dy minus df2 over dz, all times by E1, then minus df3 all over dx minus df1 all over dz, all times by e to the 2, and then finally df2 all over dx minus df1 all over dy, all times by e to the 3. First we take df3 over dy, which is the partial derivative of y of f3, which is z squared all over x plus 2z squared. As there are no y terms in the equation, this equals 0. Then we do the derivative of field f2 over dz, which equals d dz of y squared plus log xz. This first equals 0, as y squared you cannot take the z derivative of, and then it equals 1 over xz times x, which comes out as 1 over z. We then do the derivative of field 3 over dx, which is the derivative of x for z squared over x plus 2z cubed. We had to use the quotient rule for this, so we take u to equal z squared and v to equal x plus 2z cubed. Du over dx equals 0, as there is no x term in u, and dv over dx equals 1, as we're just differentiating x in this. Using the quotient rule, we then do v times du over dx, which comes out as x plus 2z squared times 0, and then minus u dv dx, which is minus z squared times 1, and this is all over v squared, which is x plus 2z cubed all squared, and this comes out as minus z squared all over x plus 2z cubed squared. Next we're going to take the derivative of field 1 with respect to z, so we're taking x squared e to the yz with respect to z, which equals x squared times y e to the yz, which comes out as y x squared e to the yz. We then take the derivative of field 2 with respect to dx, which equals d dx of y squared plus log xz y squared has no x derivative to differentiate, so this equals 0. And then taking the x derivative of log xz equals 1 over xz times z. So this comes out as 1 over x. And finally, we're going to do df1 over dy, which is equal to x squared eyz, which will be equal to x squared times z e to the yz, which equals zx squared e to the yz. Finally, substituting back into the original equation, we get minus 1 over z times e1 minus z squared all over x plus 2z cubed squared minus yx squared e to the y z e2 plus 1 over x minus z x squared e to the y z times x3.